Today we're gonna start with one more new protocol, that is a STP. I think I mentioned about this STP when we were discussing about the Ether channel, right? So what exactly is this Ether channel? Sorry, the STP. Yeah, okay, spanning tree protocol.
We can control the loops like forming
Okay. When
it's continuously transferring the data packet, so it will form in the loop. So to stop that loop, we can use the STP.
yes,
It prevents looping of data packet and broadcast. When we have two routes for transfer of a packet for same destination.
exactly when you have multiple paths to send the what do you call data. Okay. So in that situation, the loop will be created. Yes. So you can find it here. Let's suppose like we have a topology like this. Okay. These are my switch 1, switch 2, switch 3. Okay, these are my switches. Now, how many paths I have from switch 1 to switch 2 and switch 3 to reach switch 2 and switch 3? How many paths I have? Only one. Okay. So just to have redundant path. What do you mean by redundancy? Again, it's a backup path. Yes. If the primary fails, then the secondary has to take over. So in that case, what I'll do, I'll just connect these two switches just to get a multiple path, just to get a redundant path to reach the destination. Now, from switch 1 to switch 2, I have two paths. One is directly, one is through this switch 3. And same for switch 3 also, directly and via switch 2. So these are the redundancy. But what is the what do you call problem here we have? That is, let's suppose we have a PC is connected to this switch, okay, and that is generating an ARP request packet to one PC which is connected to this switch 3. Okay. So what do you remember ARP request packet? Obviously it is a broadcast packet. Yes, that means at the destination MAC address it will be having 12 Fs. Okay. Then what it will do? It will take that packet and it will see, the switch will see what? The destination MAC address, and it will send it to all the ports. Okay. And what the switch 1 will do? It will also check what? The destination MAC address. It finds it like broadcast MAC address. Then what it will do? It will send it to switch 3. Okay. Again, the same thing will be repeated in this topology. Okay. Switch 3 will also get the same. Again, it is going to broadcast the same packet. So we call it as a broadcast storm. Broadcast what? Storm. Okay. So because of this, the network consistency will get lost. The performance of this network topology get decreased. Okay. So that's the reason we use a protocol called STP. So what does this STP will do? It will just prevent the loop by making one interface as a block port. Okay, if you make one interface as a block, then it is not going to send that broadcast storm to the next switch. Understood? You can see here if you want. Spanning tree protocol, it's a network protocol used in an Ethernet network to prevent loops which can cause serious problems like broadcast storm and network crashes. Okay, so if these switches will be busy in sending the whole broadcast storm only, then when they will be sending the other data, the overhead will be increased on these switches. Okay, just to send the same broadcast packet. Because of that, the topology, performance, that will be decreased. Okay, so when we can have this STP, okay, it helps us to have loop free topology if multiple paths are available. If comes in, this STP will comes into act only when we have multiple paths. we can't get, I mean, we don't use this STP when we don't have this link. Do we have loop here? No. Does it loop? I mean, is it going to create a loop? No, it will not, because it will send this data to the switch 1 and switch 1 will send it to switch 3. That's it. Okay, because we don't have any link between the switch 1 and switch 2. So that's the reason there is no any loop will be created. But just to have a redundancy, what we'll do, we are going to just connect these two. So in this case, what will happen? A loop will be created. That's the reason we use this STP. What the STP will do? It will make one port as a block port. Okay, again the election will take place for that. Yes. So after that, it is going to just stop the loop there only. It is not going to send it to switch 2 again. So like this, it is going to stop the broadcast stop. Okay. So why exactly we need this STP? In a typical LAN, network switches may be connected in a redundant way for a fault tolerance. But if there are multiple paths between the switches, it creates a loop. Okay, like Ethernet doesn't handle this loop well, so without STP. So that's the reason data could endlessly circulate in the same, what do you call it, topology by choking that network. So that's the reason we use this STP just to stop this broadcast storm and to make that topology stable. Understood? So for that, some election will take place. Election of what? Election of root bridge switch. Okay. Now we may ask, like, what is this root bridge switch? It's kind of a boss switch, I can say. Okay. Where after election, it is going to control the whole topology. Okay. So now we'll see how exactly the election will take place of this root bridge switch. Okay. Before that, let me tell you, all these switches will be having their own bridge IDs. Bridge ID. So what is this bridge ID? I mean, during this, for this election process of root bridge switch, we have to have this bridge ID. Okay, which is the combination of what? The priority value and the base MAC address. Base MAC address. What do you mean by base MAC address? Yes, what do you mean by base MAC address? I hope you know that switches will be having per port MAC address also and the whole device MAC address also. Whatever the whole device MAC address we have, that is nothing but the base MAC address. We don't prefer this per port MAC addresses. Okay, we prefer base MAC address for this STP. Okay. So now we'll go with the root bridge switch election. So let's suppose, just for your understanding, I'm writing it like this. I mean, still they are connected into a redundant path only. So these are the three switches what I have shown you now. Okay, just for understanding, I'm writing it here. I mean, drawing it here. Okay. Now they will exchange the BPDU packet for the election of what? For the election of root bridge switch, they will exchange the BPDU. What is BPDU? Bridge Protocol Data Unit. That will be containing some different contents like root bridge ID, next sender or designated bridge ID, and then root path cost, and then designated port ID. So these are the things that will be there in the BPDU. Okay. Now why they are so important? Let me tell you. First one is the root bridge ID. Next we have sender bridge ID. and then we have root path cost. At last, we have designated port ID. Okay, now this is my switch 1, switch 2, switch 3. And let's suppose, for an example, this switch 1 is having the MAC address as AA, this is BB, and this is CC. Initially, I mean, in a like just election, whatever the candidates they will be, electing for this position, what they will say, I am the candidate, I am the who is going to elect next. Okay, so same thing will happen here also. Every switch will say that I am the boss switch. I don't know who is there in my topology, but I am the boss switch. I am going to control the whole topology. But for that, what will happen? The election will take place. Okay, so during that election, what they will do? They will exchange the BPDU packets. Okay, what will be there in the BPDU packet? So these content will be there. Root bridge ID. So root bridge ID is nothing but what? It is we have a bridge ID default number. I'll show you it later. 32768. Okay, it's a priority value we have. It's a default value. Yes, which is given on all the switches. Yes. So 32768 plus what? Plus base MAC address. So in this switch one, in this case, we are having AA. And who is sending this one itself? That is 32768 plus AA. Okay, next we have root path cost, that will be 0 initially, and then we have this is also default value, it is a .1. Okay, so all will be sending the same thing, like here in this case 32768 plus BB. Okay, next 32768 plus BB. Next we have 0.128.1. I'll tell you what is this root path cost and all later. So 32768 plus CC, 32768 plus CC, 0.128.1. So initially they will exchange this kind of bridge protocol unit, that is BPDU. Okay, so after this there is a rule. What is the rule? Whoever is having lowest bridge ID, they will become the boss switch. Boss means what? Root bridge switch, and remaining all become what? Non-root bridge switches. So who will become the root bridge switch according to you? First it will go for what? Priority value, and then it will go for the MAC address. And if you have seen that the priority value on all the switches is what? Same. Okay, then the tiebreaker will be what? MAC address. So tell me which switch will become the root bridge switch. Switch 2, how? Did you get my question? Yes? Yes or no? We have the BPDU packet of each and every switch here. Okay, they will exchange with each other. Yes, and then after that they will compare its BPDU and the neighbor's BPDU. Okay, and out of that, what I said, for the election of the root bridge switch, they will always look for what? Lowest bridge ID. So who is having lowest bridge ID here? For that they will check for what? Priority value plus MAC address. If you check for the what do you call priority value, all the switches they are having same. Then even I said you, like the tiebreaker will be what? MAC address. Which is the lowest one here? Why are you thinking so much? A is right. Why are you thinking? Yes. So this is the lowest one. A is nothing but what? 1010. B is nothing but 1011, and then C is 1100. Okay, then the lowest will be switch 1's MAC address. So that's the reason this will be what? Root bridge switch. Now after this, you may ask like, what is the use of the root bridge switch? Now this will send the BPDU packet to the non-root bridge switches. Okay, what is the use of this root bridge switch? After the election of this root bridge switch, okay, till now each and every switches were sending the BPDU packets to each other. Now the switch 2 and switch 3, they will not send the BPDU packet, they will only receive the BPDU packet from the root bridge switch. Okay, why the BPDU will be sent? Just to see, is there any loop in the network? Okay, if the root is forming, then I have to take it over the next or switch it over to the next path. Okay, if the primary path is getting failed, then I have to switch it over to the secondary path. For that reason, the BPD will be sent. I'll show you, don't worry. Okay, so this is what the root bridge ID and sender bridge ID. After election, what this switch 2 and switch 3 will do? Instead of sending its own bridge ID as a root bridge ID, it will start sending the bridge ID as a AA. Because they will also find that this is what the lowest bridge ID what we have in the topology. Understood? So after the election, they will also admit that, yes, he is my boss. He is my manager. He is going to control us. Understood? Now, we have something called root path here. Root path cost. So this root path cost is nothing but, this is totally based on what kind of bandwidth or cable we are using. Okay, so this is the link what we are using. This is, let's suppose, fast Ethernet, and here also we are using fast Ethernet. So based on this bandwidth, we are going to calculate the, it is already calculated, we just need to use that one. Okay, so what is that? If the link is of 10 Mbps, I just take it down if you want. This is the bandwidth. Okay, next one is a cost value. If the bandwidth is 10 Mbps, then the cost value will be 100. If it is 100 Mbps, it is 19. Next is 1 Gbps, it is 4. And for 10 Gbps, the cost value will be 2. Okay, so this is what the cost value the STP will take it as a reference just to find the cost, root path cost. Okay, now what this non-root bridge switches will do? They will add its cost value into that BPDU packet. Okay, whenever this switch 1 is sending the BPDU packet towards this non-root bridge switches like switch 2 and switch 3, for that the switch 2 and switch 3 has to reply back, yes, I am alive, okay, and working fine. Yes, during that, what they will do? They will add its root path cost also. So based on this, you can find how far the switch is from this root bridge switch. Understood? So can you just tell me what will be the path cost will be here?
2.
How come 2? Fast Ethernet means 100 Mbps. What is the value for this 100 Mbps? 19. Okay, so here it is 19 and here also it is a 19. Okay, now tell me what the switch 2 will add its cost value as? 19, because only once it jump or take out a hop, okay, it will be reaching the root bridge switch. But what about this switch 3? 19 plus 19, because it has to jump twice. It has to go through switch 2. Okay, that's the reason it will add its cost value as 38 or 19 plus 19. Okay. Now we may ask like, what is this designated port ID? this is the ID where it is connected towards the root bridge switch. Okay, in this case, if you take, it is faster than at 0/1, it is 0/2/1, this is also /1. Understood? Now here in this case, switch 2, it will add its designated port ID as what? 128.2. What is this 2? It is a port ID. What is the port which is connected to root bridge switch? 0/2. Okay, this is a default number. This is a default value we have. Okay, so .2 means what? It is a port ID of that switch where it is connected to RBS. Okay, what about this one? .1, because this is where only it is connected towards the root bridge switch via switch 2. Okay, so it will be 128.1. Understood? Clear? What about this BPD packet and all? Everybody clear? Okay. Online?
Why the switch 1 root path cost is 0?
Because
For switch 1, when you compare switch 3, 19 plus 19 it is coming. Because switch 3 has to come to switch 2 and you are calculating switch 2 and plus switch 1. Same goes this side also, right? From left to right.
Yeah, it goes, but this is a root bridge switch. Every switch will try to reach the root bridge switch always. Okay. Let's suppose like this RBS is also sending any packet to switch 2 or switch 3, that will also add the root path cost. Okay, for now it is not reaching anyone, so that's the reason I just kept it as a 0. Yes, if it is reaching switch 2, then at that case it is going to give it as a 19, and if it wants to reach the switch 3, at that time it will add 19 again. Okay, it's again based on when it will send the BPD packet towards those switches. During that time, it will add the root path cost just to find the distance from this root bridge switch to the non-root bridge switches. Okay.
Okay.
Yeah. Yeah, we have some two types in the BPDU. Okay. One is a normal configuration BPDU, the same configuration BPDU what you're seeing now. Okay, that will help us to find the root bridge switch. Okay, so that is called as a configuration BPDU, and second one is the TCN, topology change notification BPDU. The name itself will tell you what it is. What it is? Whenever any topology gets changed, at that time every switch should know that one. Switch is been added or switch is been deleted in the topology. Okay, in this case, whatever the BPDU packets will be generated, so that is called as what? TCN BPDU, topology change notification BPDU. Okay, so these are the two types we have here. Okay, next we have some port roles in STP. So these port roles are really important. First one is a root port. First one is what? Root port. And second one, it's a designated port. And third one, it's a alternate port. Alternate port. Okay. Now, so what is this root port? You can see here, it is the best interface to receive the BPDU packet. What is this? It is the best interface to receive the BPDU packet. Okay, then it should be on root bridge or a non-root bridge. This root ports will be on root bridge switch or a non-root bridge switches. I said the root bridge switch will send the BPDU. And this root port is what? It is the best interface to receive the BPDU. Then tell me, this root port will be the member of root bridge switch or a non-root bridge switches. Obviously, non-root bridge switch. Okay. And on a switch, we can have only one root port. We can't have multiple root port Okay, we will have only one root port because that is the only who will be representing that whole switch. I mean connecting to the root bridge switch just to get the BPDO packet. Okay, and on a root bridge switch we will never have RP. On root bridge switch we will never have RP, that is root port. If not root port, then what port? That is designated port. Okay, on root bridge switch all the switch ports will be called as a designated ports. They all will be ready for send the BPD packets towards the non-root bridge switches. Am I clear? So it is the best interface to send the BPD packet, and on a switch we can have multiple DP. Okay, or else we can say on a root bridge switch all ports will be designated ports, all switch ports in a root bridge switch. Okay, if the port is not either root port or a designated port, that port will be what? Alternate port or a block port. Okay, so it's not either a root port or a DP port, so that will become what? Alternate port or block port. That will always be into a blocking state. Okay, we have some 5 states here in STP. In that third state is a blocking state, we are going to see later. Okay, so this alternate port will be into the block state, and this alternate port is really important in the STP. So because of this only we will be able to stop the broadcast storm what is creating in the topology. Understood? Now we will see how will be the election process for this root port and designated port. Okay, so let's have the same topology what we had. Switch 1, switch 2, switch 3, and in this case this is my RBS root bridge switch. Okay, now 0/1, 0/2, 0/1, /2, /2/1. Okay, these are the interface name. Okay, number. Then the first rule or condition of this, I mean electing the root port is what? It always look for what? Lowest root path cost. Okay, let's suppose I'm using fast Ethernet, and fast Ethernet. Okay, now tell me on root bridge switch, can we have any kind of root ports? Can we have? No? Then what port will have? What ports will be having? You can see here. On root bridge switch, all ports will be designated port. Why you are thinking a lot of things? Yes, it is a designated ports. Okay, so all ports will be DPs here. So this is also DP and this is also DP. Now we want to elect, we can't have only one root port on the switch 2 and switch 3. So which port is that one now? It's 0/1 or 0/2 on switch 2, and same for switch 3 also. And even I have given the condition also. First thing it will look for what? Lowest root path cost value. Where you will get lowest root path cost value? On switch 2 /1. Why? Because if you go directly, here it is having 19 as a cost value. Okay, if it goes via switch 3, 19 plus 19. So it will be having 38. So that's the reason this 0/1 will be as a root port. Okay, on switch 3. /1, sure. Okay, this is RP. Okay, now either of them will be the AP. So I'm going to take it as a AP. Okay, now this one will become what? DP. Okay, why? Just keep in your mind that always opposite of RP, there will be a DP. Okay, keep it in your mind. What is that? Always opposite of root port, there will be a designated port, because root port has to receive the BPDU. Okay, just to send the BPDU, we have to have designated port. Okay, next, always opposite of the AP, there will be a DP again. Why? Even though this is into block state or alternate port, this will receive the BPD packets just to say that yes, I'm alive, I'm working. Okay, so just to know that one, this alternate port will receive the BPDU packet from the designated port. Okay, so that's the reason here I have given the DP. Understood? Sure. Now, tell me of switch 2. Second switch is root port. Which one? Why? What is the net cost value? 10. Cost. It's 100. Okay. So if you go with the cost value, then you'll be having it as 100. Okay. And here it is 19, and here it is 4. So if it goes via directly, directly it is connected, it is going to get it as a cost value is 100. If it goes via switch 3, then it is going to get it as what? 23. Okay. So always it look for what? Lowest root path cost value. So now in this case, this will become root port, this will become DP, and this will become again RP, because it is having only 4 here. Okay, if it goes via like this, 119 it will be getting. So that's a very huge number for this one. Okay, so always these two will be DPs, then this will be what? AP, alternate port. Clear? And the opposite of the AP, we have DP here already. Yes, understood? Great. Now, what if the path cost value is same? In some of the cases, like we have this scenario. Switch 1, switch 2, switch 3, and switch 4. Okay, so in this case, all are using fast Ethernet. Okay, next. This is having AA, this is having BB, this is having CC, this is having DD. Okay, now tell me the port roles here on all switches. Switch 1. Switch 1. This is RBS. Sorry, I didn't tell you. This is RBS. Port roles. Both will be DPs. Okay, so this is also DP and this is also DP. Now tell me for the switch 2. RP. Okay, switch 3. RP. Why? Because it is having lower cost here. So here also it is having lower cost. If it goes Y like this, 19 plus 19 and 19. How much? 50? 57. Okay. So we have decided the port roles for, sorry, the root ports for this switch 2 and switch 3. What about switch 4? So if it goes via this switch 3, there also it is getting 38. Via switch 2, there also it is getting 38. So cost value is getting tied. In this case, what will happen? It will go for the lowest sender bridge ID. What it will do? It will check lowest sender bridge ID. Then obviously these two ports will become what? DPs. Because they are sending the BPDU packets. Understood? So these two will become what? DP, designated port of this switch 2 and switch 3. Now, what about switch 4? Sorry? This one? AP, okay, and this one? Why?
Because from switch to our packet will come from because it has a lower center port.
Okay. Yeah, what it will do? It will check which is the lowest bridge ID. Okay, where it is sending the BPDU packets towards a switch 4. It will compare this bridge ID and this bridge ID. Switch 3's bridge ID and switch 2's bridge ID. Okay, so which is lowest one? Switch 2's bridge ID. That is BBD is having. So that is the reason it will take this as what? RB. And obviously this will become what? AP. Clear? Am I clear? Sure? Okay. Next. We have a scenario like can I just change it? You want mine? Good. Okay. So in this case, now tell me. Obviously, this will become what? This one? RP. And these two will become? Both will become DP, right? Yes. Why? Because they have to send the BP2 packet towards this switch 3. Okay, so both will become DP. Now, what about switch 3? If you go for the first one, lowest root path cost, here also it is having 19, here also it is having 19, 38. So via this one, 19, 19, 38. Next, that is not working. Second one, lowest bridge ID. We have only one bridge ID where it is going to compare. Okay, where it is going to compare. In that case, that is also not working. Next, it will go for what? Lowest sender port ID. Okay, which is lowest port sender port ID? 0/2. Then that means this will become what? RP. Okay, and this will become 8. This will become root port. This will become alternate port. Clear? Understood? So if that is also not working, then it will go for what? Lowest receiver port ID. That means again, it will compare this one and whatever the port ID which is lowest, then that is going to be the root port. So this will be the election of the root ports here. Understood? And same goes for the designated port election also. First, it will check for what? Lowest root path cost value, and then it will go for what? Here in this root port, it was checking for what? Sender port IDs. But here it will be looking for local bridge ID and a local port ID. That's it. Local means what? Its own. Understood? So this will be the scenario for designated ports election. Clear? Am I clear? Okay. Next, I said like, which will be the root bridge switch? Dynamically, it is going to, whenever the election takes place, dynamically, it will select one as what? Root bridge switch. Okay, so there it is going to check what? Lowest bridge ID. Okay, whatever the switch which is having the lowest bridge ID, that will be the root bridge switch. Okay, you may ask like, don't we have any static method? Yes, we have. Yes, so what we can do? What we can do? If, what is the priority value? What is the priority value default? 32768. Okay, that's a default one. That means we can change that. Can we change the MAC address? Can we change the MAC address? No. But we can change the priority value. So that means just decreasing the priority value, you can make whatever the switch you want as a root based switch, you can make it as a root bridge switch. Okay, by just changing what? Priority value. You can see here we have two methods. One is the static configuration and the dynamic configuration. Dynamic till now what you have seen. Okay, and static means what? We just need to change the priority value with a 4096 multiple. 4096 multiple means what? 0, 4096 and 8197 like this. Again the multiples of 4096. Okay. So the command will be like spanning tree VLAN 1 priority and the value you want to give. And here the STP works for VLAN also. Okay, not only to the interface, it will work for per VLAN also. That you are going to learn it in advanced level. Okay, not here. Next, I said we have some port states, STP states in the, okay, how many I said? We have 5 states in the STP. First one is what? Disable state. So what exactly this disable state? Whenever the port is down means what? It is not functioning. That state is called as what? Disable state of the STP. Now the port is on and it started working. Okay, then it will be into the listening state. So this is where only the election will take place. What election? The election of root bridge switch, root port, designated port and the alternate port. The election will be taking place in the listening state. Okay, so you can see here election of root bridge switch, root port, designated port and the alternative port takes place here, and it will take almost 15 seconds. Just to elect all these things, it will take 15 seconds, okay, to elect. And if a port becomes RP or DP, then they will be in the listening state. Otherwise, they will be in the blocking state. Okay, if one port, if it is becoming either RP or DP, they will get into the learning state, learning of what? MAC addresses. And it is not, then it will be into the blocking state. So what is the blocking state now? This is the third state of the STP, as I already said you. In this, the alternate port, here the port exactly will not be down. Okay, the port will not be down, it will be up, but it will be just listening to the BPD packet. Why it will be listening to the BPD packet? You can say here, it will listen for the BPD packet, but it will not able to forward any kind of data. Yes, if it start to forward any kind of data, then again the loop will be created. So that's the reason it will just listen for the BPD packet. Why it will listen? If the primary path is getting failed, then again it has to take it over the secondary path. That is the reason. It will be listening for the BPDU packet. Okay. And it will not learn any MAC addresses as well. It will not forward the data and it will not learn MAC addresses, but it will just receive the BPDU packet. Clear? Next we have learning state. So here the port can read or learn the MAC addresses, but it will not forward any kind of data. Okay. So just to learn the MAC addresses of the neighbors, it will take 15 seconds again. So total STP is a 30-second process. 15 seconds for what? Election purpose, and 15 seconds for learning the MAC addresses. So total 30 seconds. Clear? And after that, they all like root port and the designated port, they will get into the forwarding state. Okay, where they will read the MAC address and forward the data packets from one to the another switch. Clear? Understood? So what was the time it was taking? Just to make one interface as up. What was the time it was taking? 30 seconds. If I'm connecting the end device, that means just like your PC or laptop, okay, or printer. So these kind of things. Okay, they don't know what is BPD packet. What is BPDU? Then why to waste this 30 seconds? Okay, they don't know what is this BPDU. Understood? They don't know who is bridge ID, what is the port cost and all. Okay, they just want to forward the data. That's it. Then why to waste this 30 seconds? Okay, on the port where it is connected to the end devices. So just to slower this convergence, okay, we use a feature called rapid STP. Okay, where it's a standard way to speeding up the STP convergence. Whenever you connect a PC, whenever you connect a PC or laptop or a printer or any kind of IP phone, okay, immediately the port will be up. It will not be learning or reading any kind of what? BPDU packet. It will not be listening any kind of BPDU packets. Okay, and it is not even need on that interface. So that's the reason we run the rapid STP on that particular interface where you are connecting end devices. Okay, so which comes with the small inbuilt features like port fast, uplink fast, and the backbone fast. In that, first one is what? The port fast. Okay, what is this port fast? It is used on access ports were connected to the end devices, just like PCs or printers, just to bypass the listening and learning state of the STP. So instead of listening and learning state, what will happen in the listening and learning? what will happen? Election process and then learning of the MAC addresses. So total it will take 30 seconds. So why to waste this one? So directly it will go into the forwarding state. Instead of being in listening and learning, it will directly go to the forwarding state. Okay. So here the ports transition directly to the forwarding state, significantly reducing startup time when a device is connected. Okay. So basically it is applied to ports where the loops are unlikely. Can we expect any loop when we connect the end devices? Can we expect? No, right? Because only one single link will be connected in between this switch and a PC. So can we get any kind of loop there? No. So in that situation, we just enable the what? Port fast on the interface. Okay. So this is the command to enable the port fast. Okay. Next we have root guard. So these are the different features of this STP. Root guard. So name itself will tell you what it does. It is going to guard the root port. Okay. Or a designated port, I can say. Yes. So it prevents the designated ports from becoming the root bridge in scenarios where a superior bridge ID protocol data invoice is received. Let's suppose this is a scenario, okay, where dynamically one switch is elected as a root bridge switch. Let's suppose this is a root bridge switch. Root bridge switch. Okay. And what I'll do, just attacker like him, okay, he'll come up with his own switch, okay, by decreasing the priority value. Okay. When he decreases the priority value, then obviously if he connects to this one, what will happen? Immediately they will exchange the PPD packet and this will become what? Root based switch. Why? Why it will become root based switch? Because it is getting the lowest bridge ID there. Because it is having what? Lowest priority value. So that's the reason it will become immediately root bridge switch. That means now the attacker is having the what you call control of this whole topology. He can monitor everything. Yes. So just to prevent this one, we'll be enabling root guard on this interface. This means what? You have to enable it on every interface where the switch is connected to the other switch. Okay, you can see here. If a superior BPD is received on a root guard enabled port, then the port will be placed in a root inconsistent mode. That is nothing but the blocking mode. Okay, so where we have to apply this one? It is applied to the ports where the root bridge must not change, where the ports are connected to the other switches. So in this scenario, we have to enable the root guard on all the ports where it is connected to the other switches. Okay. So it will do what? Even though it is getting a superior bridge ID, then it will not allow that particular switch to become the root bridge switch. Always this switch 1 will be the root bridge switch. Yeah. This is what the root guard is. Next we have loop guard. So what is the loop guard? It is a protect against loops caused by the unidirectional link failure or a loss of BPD on the non-designated ports. Okay, let's suppose again we have the same. So whenever this interface, that is actually what? AP. Okay, whenever this interface stops receiving the PPD packet because of some cable failure or something, interface problem or something, if it stop listening to the PPD packet, at that time, again what will happen? Loop will be created. Okay, so if a BPD stop being received on a blocked port, the port is placed in a loop inconsistent state. So just to prevent it from transitioning it to the forwarding state. So if it is not listening, then how this what you call the root bit switch is going to understand this is what the what you call block port we are having, it's working or not. Okay, so if it is not working, then I can send it to the or switch it to the next path I have. Okay, how it is going to decide it immediately. So that's the reason it has to listen to that BPD packet. Okay, for that you have to apply it on the non-designated ports in a redundant topology. That means on the AP you have to enable this guard loop. Okay, next we have two most used features. I mean very famous features like BPD filter and BPD guard. So wherein BPD filter is nothing but what? It is going to disable the port fast and enables a STP. Okay, like it is going to control the transmission of and reception of the BPDUs on a port. So where we can do this one? I mean, where we can find this one? You can see here, we can do it on both global and per port also. Yes, you can enable this BPDU filter, and I mean, if you want to enable the STP, normal STP from the port fast. Okay, and let me tell you, whenever you enable the port fast on some interface, that will be disabling the STP. STP will not be working there. Why? Because it will not be in the listening state or a blocking state or a learning state. It will be directly going to the forwarding state. So that's the reason the STP will be disabled there. Okay. If you enable this, I mean, if you give the BPD filter globally, it is going to prevent the sending BPD on the port fast enable ports. If you enable BPDU filter on that interface where the port fast is already enabled, on that the switch will not send any kind of BPDU. Okay, if we do it on per port, it is going to suppress the BPDU transmission and drops received BPDUs. Let's suppose like I have enabled the port fast on this one. Okay, and the attacker he come and connect his switch. Okay, and here port fast is also enabled and BPD filter is also enabled. In this case, this port will not, I mean, when it gets the BPD packet, it will become what? STP again. That means again the loop will be created. Okay, this is also switch, this is also switch, and the switches has their own job like exchanging what? BPD packet. Okay, when this port fast is getting a kind of a BPD packet from the other end, then it will become what? This will disable the port fast and enable the STP. Okay, in this case, just to protect from that one, we will enable what? BPD filter here. Even though it is getting any BPD packet from the other end, it will not accept it. It will just drop the BPD packets there only. So in this situation, we use the BPDU filter. Now we have BPDU guard. What is the BPDU guard? It is going to enable the port first by disabling the STP. So it protects the network from loops caused by the connection of unauthorized switches to access ports. Okay, let's suppose initially we are connected. This is my switch here. Okay, and on a port fast enabled, okay, we have connected the two PCs here. Okay, one attacker will come and he'll connect his switch here. He'll connect his switch, then what will happen? They will exchange the BPD packet. So even though it is a port fast, it will start getting the what? BPDU packets. Okay, so just to stop that one and to make it into error disable mode, okay, we use this BPDU guard. You can see here, if a BPDU is received on a BPDU guard enabled port, then the port will be placed into error disable state. If it is getting any kind of BPDU from the other end where the port fast is enabled, in that case, it is going to place these ports into error disable mode. Then that means it is not allowing any kind of data from these two ports. Okay, I hope you know that error disable, how it looks like. You have seen it in port security. Remember? So which is applied to the access ports with a port fast enabled. Okay, so these are some different features of the STP. Okay, let's see. You just see how much time it will take. All are orange now. Okay. Does it take 30 seconds or what? We'll just wait for it. It took almost. Yes. Now tell me which is a root bridge switch. Guess, just take a random guess. Is it a switch 0, switch 1 or switch 2? Switch 2? Is it visible? Switch? 0. For sure? Okay, let me show you. Can you see the MAC address there at the end? Whatever the VLAN 1 MAC address is there, that is the base MAC address. Can you see that? What is that? 000C is there. Okay, now this one. 0010. What about this one? Now tell me. Switch 2 is the root bridge switch. Okay. So if you want to see the base MAC address, you can see here. Yeah, there it is. Base Ethernet MAC address. That is this one. Okay. So if you go for this one, and if you don't get it here, just say show version. There will get it. This is also base MAC address. Okay. This one is a base MAC address of the third one. Now we'll see what it says. Enable and just say show spanning tree. There it is. What is this one? 32769. It will add a separate system ID with that one. I said it's a default one. 32768. and it will add its system ID. It's a VLAN ID. It's going to add with that one. Okay, it will become what? 32769. And what is the address of this one? This one, 400C203739. And what it says? This bridge is the root. That means this switch is what? Root bridge switch. Okay, so again, the priority value also, the sending bridge ID also same because it is having the lowest bridge ID. Okay, and they will say hello to each other for every 2 seconds. Okay, and if the switch is down, that they will wait for 20 seconds. After that, it will switch it over to the next secondary path. Okay, next you can see here, what is this one? Path Ethernet 0/2. 1 second. Faster than 0/2, that is into, it's a designated port, and /1 is also designated port. Same thing I said you, all the ports of the root bridge switch will be the designated ports. Next, both are into forwarding state. What is the cost it is showing? 1919, because we are using fast Ethernet. Okay, and whenever you are doing the practical, you just take a gigabit Ethernet. Okay, you can see there at the end we have 2 gigabit Ethernets. Okay, so how to select that one? You just go to this crossover cable and click on this one. Here it will allow you to select one cable. Okay, you just go to this gigabit Ethernet and connect it to the other end. Just try what the cost you will get at that time. Okay, and same thing, 128.2. 2 means what? Where it is connecting to this switch 0, and this is 128.1. This is connecting to this one more non-root bridge switch, and it is a point-to-point connection. Okay, now let's go to this switch. It is one of the non-root bridge switch. Enable and just say show spanning tree. There it says my root ID is who is having the address as 400C203739, and mine is what? This one. I mean, this switches bridge ID is what? 32769 plus 000C8521D083. This is what the bridge ID of this switch 2. Now tell me, like, what is this faster than 0/1, which is a designated port, and that is also into forwarding state, and /2, it's a root port that is also into forwarding state. Okay, let's go to this switch 3. So here one will be alternate port and other will be designated. To spanning tree. There it says my boss is who is having priority value as 32769 and the MAC address has 4 zeros. Okay, and mine is this one. And /2 is a root port and it is into forwarding state, and /1 is what? Alternate port, and this is into blocking state, and both are having cost as a 9. Okay, understood. Now I just want to make this switch as what? Root bridge switch. So how I can do that? Decrease the priority value. So let's do that. So config key and spanning tree VLAN 1, and you have to say priority. If I say question mark, it says like just give the number in increment of 4096. Can you give me 4096 into 2? Huh?
92.
92. Sure. 8192. Okay. So you can see here behind something is happening. That means again the STP is working there. Okay. So let's wait for that one. What happened now? Now this become what? Road based switch. Okay, even though having highest MAC address, but it is having lowest priority bundle. So that's the reason it become root bridge switch. If we want to check, do show panning tree. There it is. It says that this is a bridge. I mean, this bridge is a root. Okay, because it is having priority value as 8193. Okay, now both are into designated reports and forwarding state. Okay, now this become what? One will become block state, another will become forwarding, and it says like this is the root because it is having priority value as 8193. Okay, now we'll go for port fast. So I will take two PCs. Okay, on /3 I'm going to enable the port fast, and on /4 I'm not going to. Okay, so config the interface path ethernet 0/3, and here panning 3 port fast. Okay, just say enter. Done. Now just connect this one with the port /3. What happened? Immediately it went up. Let's connect to this /4 and let's see what happened. You may see here. Still it is learning the MAC address. Still it is into listening and learning state. Directly not going to forwarding state. Okay, so this is what the port fast is. Instead of wasting 30 seconds, directly we make that interface as a up. Okay. Now we'll go for port fast is done. Root guard. Okay. So instead of this PC, what I'm going to do, I'm going to connect one switch where it is having superior BPDU. Okay. So I will take one switch and I'm going to decrease the priority value of that one. Okay. But before that, I have to enable root guard on this interface. Which interface? Am I into /3 now? Okay. Panning tree guard root. Okay, enabled here. So before that, let us change the value of this one. 4096 because already we have value as 8192. Let's say enter. Something is array root. 4096 done. Okay, so let's connect this one to the switch interface. Can you see there? No. Yeah, no. That port is in still locked. Okay, it is not getting up. Okay, even though I'm fast forwarding it, you can see there it is not getting up. Okay, you can see here. If I show you, still this is what root bridge switch. So which is this one, right? Yeah, anyway. Still this is, I guess. Yeah, still it is root bridge switch. Okay. What if I connect directly to this one? Now, which is the root bridge switch? New one. Why? Because I didn't set any guard mode on this actual root bridge switch. Okay, I did it on non-root bridge switch. Let's check here. Show spanning tree. It says that I am the root. I am the root bridge switch. Before this one was okay, but now this is not. This is not. It says that someone called 0009, they become root bridge switch because they are having 4096 as a priority value. Okay, understood? That means we have to enable this root guard on all the interfaces of this root bridge switch, where it should not get what? The higher BPDO packets. Okay, understood about the BPD guard? Sorry, this root guard. Clear? This loop guard, it's not supported in the STP, sorry, the CPT. Okay. Let's go for the BPD filter and BPDO guard. What is BPDO filter? What I said? What I said? Will disable. What I said? What are you looking at? Yes. Okay. This will be task for you. Okay. So just check how this behaves when you enable BPD filter and BPDO guard. Understood? You have your what do you call commands here. Okay. Just take a scenario and you just try it. Done. Tomorrow I may ask anyone just to show it on your laptop. Understood? Clear, everyone? Hmm. Which guy? That is applied to only the root bridge switch. That should not get the higher BPD. Yes.
Sir, why the value is 4096?
4096.
Yes, the priority value need to be changed. The
Which
format
one?
of 4096.
This one.
While the priority value, we need to change the root bridge. So we use the value 4096, right? So why the value is 4096?
You mean like why exactly the 4096?
Yes, yes.
I don't know exact answer for that. Okay. Let me check it and answer you. Okay.
Yes.
Okay. Because it is already predefined. Okay, we have a small two protocols. We'll go through that. Okay. And we'll finish it today. Yeah. Two protocols, that is, these are the two discovery protocols that we use during the troubleshooting. Okay. This will help you during the troubleshooting mostly. They are like CDP and LLDP. CDP is nothing but what? Cisco Discovery Protocol, and LLDP stands for what? Link Layer Discovery Protocol. Okay. So in that first one, CDP, what is exactly used for? Both are used for what? To find the neighbor information like IP address, VLAN, version, device identity, like what is the host name and model of that one, and then capabilities like whether it is a switch or a router, and what duplex mode it is working. So all these kind of information of neighbor should be learned with the help of this CDP and LLDP. Both will be helping us in the troubleshooting purpose. And out of this, the Cisco Discovery Protocol, it's a Cisco proprietary protocol. Okay, that means it will work only on the Cisco devices. Okay, so it is used for troubleshooting of the network issues, and it uses a multicast address that is 0100.0CCC.CC just to send the CDP messages or packets to the neighbor. Okay, so if the devices say they are getting the MAC address like this one, okay, so they find it as what? It's a CDP packet. Yes, and it works only on Cisco devices, just like the switch, router, firewall, IP phones, etc. And it is a by default. You don't need to enable this one by manually. Okay, on Cisco devices, it will be working by default. Okay, and we have some two versions here, CDP version 1 and CDP version 2, and version 2 is the default version, which will be running on the devices, and it is having some two timers. One is hello timer, that means for every after 60 seconds they will say hello to each other, they'll say hello to the neighbors, and if the neighbor is down, it is not replying for the CDP hello packet, then it will wait for 180 seconds, and after that it will be removing the information of that neighbor from the CDP table. Okay. So to enable the CDP, we just need to go on the global or per port also you can do. Okay, you just need to say CDP run. And if you don't want to, no CDP run. That's it. And if you want to change the timer of this hello, you see it seems like it's very what do you call it? Duration is very lowest one. If you want to increase this one, then you can increase it by using this one CDP timer, and then you have to give the timer in second. And then we have this hold timer. That also, if you want to change, you have to say timer hold time, then the timer you want to give. Same goes with the LLDP also. But LLDP is a open standard protocol. That's what the difference we have here. Okay. LLDP, this is also find the neighbor information, just like what IP address, VLAN, version, device identity, capability, and duplex. Okay, this is also used in troubleshooting of the network addresses, and it also uses the same MAC address. Okay, just to send the LLDP message or packets, but it is a open standard protocol. That means it works on both Cisco and non-Cisco devices. Okay, but here it is not a default one. You have to statically enable this one. If you want to enable, you have to do it statically, I mean manually. Okay. So, but we can't run CDP and LLDP protocol at the same time on a single device. Either you can go for CDP or you can go for LLDP. Okay, not same at the same time on a single device. And the hello timer is of 30 seconds, and it's going to wait for 120 seconds. After that, it's going to remove the information of that neighbor. Okay. So this is what the CDP and LLDP. Okay. So these are some show commands. So both having the same show commands, instead of CDP, you'll get your LLDP. Okay. So let's check it on the devices. If I say show CDP here, says like sending CDP packets every 60 seconds and sending a whole timer value up to 180 seconds. And which version it is using? Sending CDP version advertisement is enabled. Okay. Now, if I say show CDP question mark, so these show CDP. So these are the interfaces and neighbors. So I'm going to see the neighbors here. Okay. So these are the neighbors what I have. Okay. So what are the neighbors? It is having switch 1, the switch 0, switch 3, switch 2, and the router. Same thing you can see here. So 3 switches and 1 router. Okay. On fast Ethernet 0/1, it is connected with a switch. So let me again enable that one. On fast Ethernet 0/1. So where exactly it is? Yeah. 0/1, where it is connected to switch 3. Yeah. Okay. What is the hold timer? That is 120. Will discuss what is that hold timer and all. Okay. What is the platform? Which model it is using? 2960. You can see here. What is the model we are using? 2960. Okay. And port ID. What is the port where it is connected with? To that foreign device. That means this device. What is the port ID of that one? Fast Ethernet 0/1 here. Okay. And on /2, it is connected with one more switch. Okay. So it is having 2960 and capabilities means what? Yes. So if you don't understand, you can see here the codes. S stands for what? Switch. And R stands for what? Router. Okay. So different thing we have here, you can see. And when it comes to router, it is connected to faster than 0/4. This is the whole timer. Next is capability R and which platform it is using. You can see here. 2911. Okay. 29, sorry, C2900. So this is a version of that one. Okay. So where it is connected to the gig Ethernet 0/0 of the router. Okay. So this is how it is used to find the neighbors. And let me show you one more thing. Can you just go on seeing those whole timer? Okay. Are they varying? Yes. Now let us wait. Any one of it reaches the 120. See the first one. It is decreasing. Okay. And I said whole timer is what? Whole timer is 120. Okay. Now what it will do? It will take this whole 120 and it is going to take the hello timer for only 60 seconds. So after 60 seconds, it is going to back to the again 180. Okay, you can see here 120. Now going back to the 178. Understood? Now what I'll do, I'll just make this interface as a down. Switch faster than 0/1. I'm going to make it as a down. So config C interface faster than 0/1, just say shut down. Okay. And your CDP neighbors. So 55 is there, 52. Okay. So let's wait for that until it reaches the 120. So now it will not go back to 180 again. Again, it will start decreasing like that. 140, 139, wait for it. 128, 22, 21, 19. What we are seeing? After 120, it again go back to the 180. But this time it is not, because it is not getting any kind of reply from the neighbor. Okay, that's the reason it will start counting from that 120 and below. Okay, 100 now, 99. So let's wait for that. Once this reaches the 0, then the whole information of the switch will be removed from this CDP table. Okay. You can see other also, other timers. The third one, which is connected to switch 3, 134, 132. Okay. Again, when it reaches this 120, it will go back to the 180 again. So there you can see. See, it reaches the 180. Okay. 1 gone. Okay, you can see here the information of this switch is gone. It is only showing 3 switches, sorry, 2 switches and a 1 router. Okay, so based on this, you can find 1 switch is down now. Okay, understood? If I make that interface again up, then you can show it again in the CDP table here. Interface faster than 0/1 and just say no shut down. There again. Okay. Yeah, sorry, here it is at the end. It is newly added to this CDP table. Okay. This was the CDP. Now I just want to run LLDP on all the switches. So first I have to disable the CDP. So how to do that one? Config C and just say no CDP run. Okay. And on other devices also I have to do the same thing. Enable config T no CDP run. On router, enable config T no CDP run. Okay, done. So instead of CDP, I'll just say LLDP run. Okay. So on this switch also, I'll say LLDP run. On this switch also, I'll say LLDP run. Okay. When I say show LLDP neighbors, it will say it will show you only one, showing only one. Why it is showing only 2 devices? Why it is showing only 2 devices? Because I'm running LLDP on this switch and a router. That's the reason it is showing 2 devices. If I say show CDP neighbors, it says like CDP is not enabled. Okay, because I disabled it, right? The router, and here the whole timer will not change. It will be constant to 120. Okay, again we have to wait for 120 seconds and then it will be removed automatically. Understood? The total entries is 2 and the local interface of this switch is what? 0/4. That is nothing but this one. Okay, and whole timer is 120 and capabilities are, that means what? It's a router. Okay, port ID of that router is what? Gigabit Ethernet 0/0. And your switch it will take it as a bridge here. Okay, capability you can see here. It is a B. Yes. So it is connected to the local fast Ethernet 0/3 and the whole timer is again 120 and the interface of that switch is what? Fast Ethernet 0/2. Okay. You can see there it will not be changing. Okay, let's do one thing. Let's go to this router 0. Let's say config the interface gigabit Ethernet 0/0. Just say shut down. Okay. Till there. Okay. So wait for 120 seconds and then it will be removed from the LLDP table. Understood? Yeah, these are the two discovery protocols we use in network. Okay, one is CDP, which is a Cisco proprietary, and LLDP, it's a open standard. That means we can use it on both Cisco and non-Cisco devices. Am I clear, everyone? Okay. It's not 2 minutes yet. Fast forward my good luck. Okay. It's gone. Okay, router is gone. Done. Yeah, this is what the today's thing. We learned STP and two more discovery protocols, that is CDP and LLDP. Okay, so I think this completes this your switching part. Tomorrow onwards, we're gonna start with your router. Okay, so it is 16. Okay. See, we have a lot of time. When you started your batch? Second, right? Second. Okay. Okay, then we'll wind it up here.
Sir, what a hello.
Yeah.
Yeah, task. What about the previous class task?
I think I said it right. Without ACL, that is not possible.
Okay.
Did you even try to find it?
Yes, sir. Just Friday. I think ACL need to be activated.
Yeah, ACL is to be configured. Then only it will be allowed or drop the traffic.
Yes, sir. Okay. Thank you, sir.
Yeah.